Aloha and welcome. In this lesson, we're going to be talking about ARP poisoning, MAC flooding, and MAC cloning. So I'd like to start out by saying that we're going to be working here in this video with layer 2 of OSI model. And I talked a little bit about the OSI model before. You're going to be, we talked about layers 3 and 4 that we use, and layer 7, which is the application level layer. So we're going to be talking about layer 2 exclusively here. And when I talk about layer 2, I'm talking about essentially Ethernet. And Ethernet, we're talking about communication on something called a switch. So this is a switch you can see here. It's a standard, it's a Netgear 8 port gigabit switch. And these are what we call ports. So we plug into a port with an Ethernet cable. I have Ethernet cable right here. So you would take one of these ends and you just plug it into here. You see, you plug into there, and then you take the other end and you bring this to your computer, you plug it in there. Now we have wireless, but if you're using wired connections, you would use these. So essentially, when you're doing your communicating with other devices on the network, you have something in there called a MAC address. It's etched into your network card on your computer has a MAC address that's etched into it. And that MAC address is permanent, but it can be faked. Don't worry about that right now. We'll talk about that. But you have this MAC address that uniquely identifies your network device. So it's a 48-bit identifier. Part of that is the identifies the manufacturer of the equipment. Part of it is just the serial number that they use. But that MAC address is unique to you. So when you connect to the switch, you're letting it know your IP address and it's going to keep track of the port number and the MAC address. So it's going to know that relationship between the two. And when you are setting up communication with another device, once you're in there, let's say we were on port 1 over here, and then port 2 was a printer or something like that. Whenever I'd have to communicate with that one, it would the switch here would just send the data directly between these two ports. It wouldn't send it out to everybody on the network. So what we're doing here is it's more efficient when you have things like that going on, because if the switch knows which two devices are communicating with each other, it makes it where all the communication is going to happen here in isolation of everybody else. It's not going to be sending out lots of broadcast activity here. So anyway, getting back to the idea, this thing has that address table, the MAC table in it. It's going to have the MAC addresses for everybody that connects to it, and the port number, so it can set up that communication. This is going to be important for some of the attacks that we talk about coming up. But just know that everybody has a MAC address. That MAC address uniquely identifies the network equipment that you're using, and that's how it sends it out. So, and all this is happening on what we call layer 2 of the OSI model. So let me go ahead and share our screen here, and we're going to look real quick at the OSI model. So OSI model, we're talking about layer 2, the data link, and this is going to be connecting node to node transfer between devices on your network. So going back over here, we're talking about layer 2. Ethernet is layer 2 protocol. So I mentioned already that everybody has a MAC address. That MAC address is 48 bits, and it looks like this. It's written in hexadecimal, and it's 6 groupings of 2 hexadecimal digits. And you'll see this probably written directly onto your network card if you still have a standalone network card. And your computer is using something called Address Resolution Protocol, ARP. And that's where it resolves the internet addresses from layer 3, like 192.168.1.1, into MAC addresses that look like this highlighted thing here, DAC4, 97C3, 3ED. So that's how it goes from layer 3 to layer 2. So an ARP cache table, or an ARP cache, is a table that maps an internet address to the internet address's corresponding MAC address. To deliver a data packet, an ARP cache table is used to find the MAC addresses that maps to the data packet's destination IP addresses. So that's how the magic happens. So now talking about the data link layer attacks, we've got 3 different ones we're going to discuss here. One is the address resolution protocol poisoning. and or ARP cache poisoning, ARP spoofing. That's an attack where the attacker sends spoofed ARP messages on a local network to associate the attacker's MAC address with the IP address of a target host on the LAN. So the bad thing about ARP communication, the protocol doesn't have any authentication on it, so anybody can claim to be anybody else. So you can kind of spoof someone's address. So if you wanted to steal all stuff that was going to the printer, you would just go and send out a message, an ARP message saying, "Hey, I've got that MAC address." You give it, you say that, "Oh, I'm actually, this MAC address." So then it'll start sending you all of the data that was supposed to go to the printer. So that's not a good thing. The other thing we have here is media access control flooding. And this is an attack where you send a large number of invalid MAC addresses to that network switch we were talking about. And when you do that, what's going to happen is the MAC table, that table that keeps a track of everybody's MAC address and what physical port they're on that switch, if you overwrite that whole thing, a couple of things are going to happen. One is, let's say you're overwriting, you're going to put false data in there. You're basically going to put junk in there so that it can't send it out. And when it realizes that it can't send it, if it doesn't have the MAC address, the proper MAC address for somebody, when a new packet comes in saying, "Hey, I'm sending this to this MAC address," and it's not in its list, then what happens is it sends it out to everybody in what it calls a unicast flood. So it will send it all to all ports on there. So you've done two things here. One thing is instead of having it go one port to one port, which is really efficient, you're going to be sending out the same broadcast transmission to every single port on there. So you're going to see a degradation in your performance. But also the thing is, whereas that communication was private before, now it's going out to everybody. So anybody can sniff the packets, the information that's going through there. They can see all that data, and they can try to to make sense of it as it goes through. So that's a insidious little thing that happens there. So that is what we call a MAC flooding attack. And then the last thing we're going to talk about is MAC cloning, and that's also called MAC spoofing, and that's the act of changing the factory assigned MAC address on the network device. So MAC addresses are physically on there, but you can use software that will clone or fake an address. So you can fake somebody else's MAC address and use that. So that's the one way you can you can go out there and put a rogue device on a network and have it try to steal all the, let's say, the printer traffic or something like that. And they show a nice example of ARP poisoning in here as well. So that is it for this section. But again, just know we're dealing with the OSI layer 2, which is the data link layer. That's where the physical addresses, the media access control address is used, and that's stamped onto your network card and uniquely identifies your network device. We have ARP. This basically it's your MAC address to IP address table that's in your computer, and those can be poisoned by people going out there and claiming to be MAC addresses that they aren't. So that's one thing. And then we've got the MAC flooding where we just go and overwrite the table in that switch that I showed you. And then once it's overwritten with all this bad stuff, it just starts sending out data to everybody, which slows down the system, also makes all the traffic visible. And then we have MAC cloning, which is the ability of a system to claim that there's somebody that they're not. So that's the data, or that's the information I need you to glean from this lesson. I hope you found it interesting. If you have any questions about the OSI model or anything else, feel free to ask me. I'm here for that. So have yourself a good day, and I'll see you in the next video. Aloha.